In the wake of African swine fever devastating the livestock industry, China has built massive pig skyscrapers, capable of producing more than 1 million pigs per year. But how do these high-rise pig cities actually operate behind the scenes? From herds of pigs living dozens of meters above the ground to highly automated systems running almost every part of the operation, this model is pushing livestock farming into an unprecedented era of industrialization. Today, let's step inside China's gigantic pig skyscrapers and see how an entire farming industry is being operated like a colossal machine running non-stop. After the devastating outbreak of African swine fever, which led to the culling of hundreds of millions of pigs and caused pork prices in China to surge, the country's livestock industry entered an unprecedented industrial revolution, raising pigs in massive high-rise buildings. Instead of traditional farms spread across vast areas of land, Chinese companies began constructing pig skyscrapers, apartment-like complexes for pigs reaching 6, 12, and even 26 stories high, with investment costs amounting to billions of yuan. These facilities are equipped with extensive automation systems, air filtration, waste treatment, and disease control technologies operating 24/7. One of the most well-known examples is located in Ezhou, featuring two 26-story buildings capable of producing up to 1.2 million pigs per year, currently considered the largest high-rise pig farming complex in the world. Inside these pig apartment buildings, everything operates more like a high-tech factory than a traditional farm. Each floor is assigned a different stage of pig development: breeding, farrowing, weaning, fattening, and finishing before shipment. The fully automated feeding system transports food through sealed pipelines directly to each pen, allowing precise control of feed portions for tens of thousands of pigs at the same time. AI cameras and smart sensors monitor body temperature, movement, vocalizations, growth rates, and even abnormal behavior to detect illness at an early stage. Some farms even apply facial recognition technology for pigs, enabling extremely accurate individual tracking. Especially, even the movement between floors is mechanized, as pigs are transported via specialized elevator systems, functioning as part of an automated production line. Environmental technology is a critical part of the system. Air inside the buildings is continuously filtered through negative pressure ventilation systems, sterilized with UV light, and cleaned using biofiltration to reduce the risk of viral contamination. Workers entering the facility must go through multiple biosecurity checkpoints, change into protective gear, and undergo disinfection procedures similar to those in biological laboratories. Pig waste is collected through a closed-loop system and then processed into biogas for electricity generation or recycled as fertilizer. Thanks to this vertical design, land use can be reduced by 50 to 70% compared to traditional farming, a crucial advantage in densely populated areas with limited agricultural land in China. The biggest advantage of vertical pig farming is its scale and level of control. Within a single complex, companies can raise hundreds of thousands of pigs while requiring significantly less labor than traditional farms. Automation helps reduce feed costs, improves disease control, and accelerates growth rates by maintaining an optimized environment at all times. Large companies such as Muyuan Foods and Zhongxin Kaiwei even operate real-time data systems to adjust temperature, humidity, and feeding programs for each stage of pig development. A single worker can monitor thousands of pigs through computer screens instead of manually inspecting each housing unit. However, this model has also sparked intense controversy worldwide. Many experts worry that concentrating such a large number of livestock in a confined space could turn a small outbreak into a large-scale disaster if biosecurity systems fail. In addition, odor, wastewater, and noise from these mega farms place significant pressure on surrounding residential areas. Some residents living near pig skyscraper facilities in China have reported that they were forced to move away because they could not tolerate the smell and pollution. Animal welfare organizations have also criticized the system, arguing that pigs spend almost their entire lives in enclosed concrete environments with little natural light and limited space for movement. Despite the controversy, vertical pig farming is increasingly becoming a symbol of modern industrial livestock production. Instead of traditional sprawling farms, tens of thousands of pigs are now raised inside massive buildings that operate much like high-tech factories. From feeding robots and AI health monitoring systems to air filtration and waste treatment converted into biogas electricity, nearly everything is automated to optimize production at an extreme scale. In the future, these pig skyscrapers may become a familiar feature of the global livestock industry. When disease outbreaks occur in vertical pig farms, response measures must be carried out extremely quickly to protect the rest of the herd and prevent the virus from spreading. Pigs showing abnormal signs are immediately isolated for monitoring, while suspected infection zones are quickly locked down and continuously disinfected. For highly dangerous diseases such as African swine fever, which currently has no effective cure, infected herds are handled according to strict biosecurity protocols to safeguard the remaining livestock system. Afterward, barns and all equipment are thoroughly cleaned and disinfected before being brought back into operation. Because of these risks, modern farms are investing heavily in AI, sensors, and 24/7 monitoring systems to detect diseases as early as possible, minimize losses, and reduce the need for large-scale culling. In China, ducks are one of the largest-scale livestock industries in the world, with hundreds of millions raised each year for both meat and eggs. In modern farms, ducks are often raised in massive flocks inside barns, stretching hundreds of meters long, where feeding and watering systems operate almost continuously throughout the day. After hatching, ducklings are moved into heated brooding areas to maintain stable temperatures before entering a rapid growth stage. Thanks to their fast growth rate and strong adaptability to wet environments, many meat duck breeds can reach market weight in just a few weeks. Meanwhile, egg duck farms can produce tens of thousands of eggs every day to supply China's enormous food industry. From salted eggs and century eggs to countless traditional dishes that use duck eggs as a key ingredient. However, in many agricultural regions of China, ducks are not raised solely for meat or eggs. Farmers also integrate them directly into rice fields through a system known as rice duck farming, a method that combines rice cultivation with free-range duck herding to reduce farming costs and limit the use of chemicals. After each harvest season, rice fields are usually left with scattered grains, empty husks, insect larvae, small pests, and snails hidden beneath the mud. Instead of letting these go to waste or relying on additional chemical treatments, Chinese farmers use duck flocks as a living biological cleaning system. Driven by their natural instinct to constantly dig through the mud for food, thousands of ducks move across the fields like natural cleaning machines, helping clear the land within just a few days. They feed on pests, reduce harmful insect populations, and are especially effective at controlling snails and young weeds, both of which could significantly affect the next rice crop. What makes this model highly valued is that it creates an almost complete economic cycle. Ducks take advantage of free food sources in the fields to gain weight naturally, while their droppings become nutrient-rich organic fertilizer for the soil. As the ducks constantly move across the paddies, they also stir the top layer of mud, increase oxygen levels in the soil, and help suppress the growth of certain weeds. Many regions in China that use rice duck farming, the integration of rice cultivation and duck raising, have significantly reduced their use of pesticides and chemical fertilizers while still maintaining high crop yields. This is also an extremely efficient economic model. In industrial livestock farming, feed is usually the largest expense, but with free-range field ducks, farmers can save a substantial amount of money by utilizing natural food sources in the paddies. A flock of ducks can be moved continuously across multiple rice fields throughout the harvest season, turning agricultural leftovers that would otherwise be considered waste into commercial meat and eggs. And in an era where livestock farming is becoming increasingly industrialized with robots, AI, and massive factory farms, China's rice duck farming system still represents a very different approach. One where thousands of ducks not only produce food, but also directly participate in the operation of traditional agriculture itself. Besides pigs and ducks, China also has a livestock industry that may sound small in scale, but is actually enormous: quail egg farming. China is currently one of the world's largest producers of quail eggs, with billions consumed every year in street food, hot pot dishes, instant noodles, packaged snacks, and the processed food industry. Although quail eggs are only about 1/5 the size of chicken eggs, they have become a common ingredient throughout China's food industry, thanks to their compact size, easy preparation, and extremely short production cycle. Quail farming operates much like a miniature industrial production line. After hatching, baby quails are moved into heated brooding areas equipped with warming systems and continuous lighting to maintain stable temperatures. Since this is the stage when the birds are still fragile and highly sensitive to environmental conditions, within just a few weeks, they enter an extremely rapid growth phase before being transferred to egg-laying facilities. Due to their small size, quail housing systems are often designed as multi-tiered cage rows, stretching dozens of meters long, allowing an enormous number of birds to be raised within a relatively compact space. Automated feeding systems continuously distribute feed along long troughs, while water is supplied through drip-style drinkers to minimize waste. Lighting inside the facilities is also carefully controlled, since the duration of light exposure directly affects the quail's egg-laying performance. One of the most remarkable aspects of quail farming is the nearly non-stop rate of egg production. Once they reach peak productivity, tens of thousands of quails can produce a massive quantity of eggs every single day. After being laid, the small eggs roll out of the cages and automatically slide onto conveyor belts below, where they are transported to sorting, cleaning, and packaging areas that operate almost entirely through automation. At large-scale farms in China, the entire process, from feeding and egg collection to waste management, is optimized to minimize labor costs and maximize production speed. However, because quails are raised at extremely high densities, environmental control becomes a critical factor for survival and productivity. Even slight temperature fluctuations or excessive humidity can quickly stress the flock and reduce egg production. As a result, many facilities operate ventilation systems almost 24 hours a day to reduce dust, ammonia buildup, and maintain stable air quality inside the barns. Quail manure is also collected continuously because, at a scale of hundreds of thousands of birds, the amount of waste generated each day is enormous. Compared to conventional laying hens, quails consume far less feed, but begin laying eggs at just over 1 month old, a speed that makes them one of the fastest return livestock species in the poultry industry. While many chicken breeds require several months before reaching stable egg production, quails grow extremely quickly and can produce eggs almost daily once mature. Their small size also allows farmers to significantly reduce housing space, feed consumption, and operating costs. As a result, the number of quails raised within the same area can be far higher than chickens, creating an exceptionally dense level of egg production. This is why many people describe modern quail farms in China as mini egg factories, operating almost non-stop throughout the day. First, we arrive at Zikang village in Zhejiang province. This small village of only about 1,000 residents may look peaceful, but it hides a nightmare for many people around the world. More than 3 million snakes of various species live together in less than 1 square kilometer, accounting for up to 10% of the country's total snake production. Can you guess what makes the locals willing to live alongside snakes? In fact, a professional snake farming household can earn between $55,000 and $68,000 per year, making snake farming a highly sought-after occupation in rural areas. The process begins with female snakes that reach the standard age of 9 to 10 months. To optimize the survival rate of the brood, farmers apply a controversial but crucial intervention technique: stitching the snake's lips with fine thread when the egg-laying season begins. The purpose of this is not to protect humans, but rather a technical measure to eliminate the female's instinct to eat their own eggs. With a yield of 12 to 21 eggs per clutch, manual collection must be carried out strictly every 2 hours. However, this is an extremely tense and dangerous period, as the mother snake remains in a defensive state, ready to strike at any moment. Collectors use a wooden stick with a metal hook at the end to skillfully lure the mother snake away from the nest. The operation must be fast, precise, and extremely cautious. Courage alone is not enough, as the price to pay could be a fatal bite from a highly sensitive mother snake. Moreover, even a slight delay can cause the embryos to die due to changes in temperature and humidity, rendering all the care efforts meaningless. Once removed from the nest, the eggs are taken to the incubation room. There, technicians inspect them using a flashlight to check embryo development and detect abnormalities. Qualified eggs are placed into incubation trays with strictly controlled temperature and humidity, while any discolored or irregularly sized eggs are immediately discarded. As they enter the growth stage, the snakes are transferred to standard cement enclosures measuring 0.5 meters in height and 1 meter in width, reinforced with sturdy steel mesh. Here, they are provided with a high-protein diet consisting of frog meat or baby chicks, fed 2 to 3 times per week. A 1-month-old group of snakes can consume up to half a kilogram of baby frogs per day to ensure rapid muscle development and the accumulation of high-quality venom. For individuals that absorb nutrients poorly or refuse to eat, farmers carry out a force-feeding process by using a stick to place food directly into their mouths, ensuring the entire group reaches the required weight before harvesting. This level of strictness is the foundation behind the immense economic value of the final products. In specialty restaurants, snake meat is prepared into stews or soups, priced between $50 and $100 per kilogram, depending on the species. In addition, snake wine remains an iconic product in traditional East Asian medicinal culture. Jars containing whole cobras or banded crates can sell for up to $1,000, based on the belief that they enhance vitality and help treat joint-related conditions. Leaving the snake farming village in southern China, more than 27 million buffalo are undergoing a major genetic transformation. For decades, this animal was shaped for labor rather than economic value. They were mainly used for plowing and freely grazed on river floodplains or steep hillsides. This farming method relies on a unique biological mechanism. Buffalo must soak in water or mud for 2 to 4 hours each day. With an extremely limited number of sweat glands, wallowing is almost the only way for them to regulate body temperature, remove parasites, and protect their skin from harsh heat. However, This nature-dependent farming approach is gradually being restricted due to strict government regulations on resource management. Large-scale free grazing has been limited in many areas to prevent forest soil erosion, protect biodiversity, and especially to eliminate the risk of water pollution caused by livestock waste. It is precisely these environmental constraints that have driven a shift toward high-tech, intensive farming models. By crossbreeding local buffalo with imported breeds such as Murrah and Nili Ravi, experts have increased milk yields from 500 kilograms to 2,500 kilograms per cycle, transforming an outdated draft animal into a true money-making machine. In Guangxi, the buffalo milk capital supplying up to 60% of the nation's total output, buffalo are no longer free-grazed but are instead raised in large-scale facilities with temperatures maintained below 30 degrees Celsius. This controlled housing, combined with automated TMR, total mixed ration feeding systems, ensures complete consistency, producing premium milk valued at up to $6 per liter, 4 times the price of cow's milk. The reason buffalo milk can command such high prices lies in its superior biological properties. It contains twice the fat yet less cholesterol than cow's milk. Notably, with 58% more calcium and 40% more iron, along with A2 protein that is easier to digest, buffalo milk has become an ideal alternative for children, the elderly, and those sensitive to lactose. In Luan City in eastern China, hundreds of millions of geese are quite literally laying golden eggs, producing hundreds of thousands of tons of feathers each year, an economic value that rivals that of their meat. Leveraging its dense freshwater ecosystem, China has come to dominate this entire industry, controlling up to 90% of global meat production and 80% of the global feather market share. The journey of a goose begins in industrial hatcheries, where temperature and humidity are precisely controlled. After collection, goose eggs are carefully inspected under light before being placed into incubators. After about 28 to 35 days, goslings hatch from the selected eggs, healthy and ready to begin a new life cycle. They are then kept warm, carefully nurtured, and provided with adequate nutrition to ensure stable development. However, for young poultry, the brooding stage is extremely sensitive. Without proper control of temperature and hygiene, goslings can die in large numbers due to disease or thermal shock. As waterfowl with high activity needs, geese require ample space to develop feathers that meet quality standards. As a result, farms in Luan typically combine enclosed farming systems with large natural water areas. After about 120 days, when they reach a weight of 4 to 6 kilograms, the feathers achieve the necessary elasticity and insulation, key criteria that unlock a multi-billion-dollar value chain. By controlling the neck, the most maneuverable part of the body, workers can quickly separate each goose from the flock and place it into transport cages, while keeping the feather structure intact and undisturbed. From there, at the factory, the feathers undergo a rigorous industrial processing line. Raw feathers are separated using airflow to classify them by weight, then pass through a series of washing, sterilization, and centrifugal drying processes to completely remove impurities and moisture. Finally, they are dried and fluffed to achieve maximum loft before being inspected and precisely filled into premium bedding products, where goose down offers superior insulation and is significantly lighter than duck feathers of the same weight. But it doesn't stop there. Goose feathers have also unlocked another billion-dollar market: badminton shuttlecock production. Few people know that to create a shuttlecock that meets international competition standards, exactly 16 nearly identical wing feathers are required, carefully selected from the healthiest mature geese, an essential factor in achieving a stable flight trajectory that synthetic materials still cannot fully replicate. No longer confined to the ground, China's livestock industry has expanded skyward, where more than 600 million pigeons operate like mobile protein production lines, ready for market in just 21 days and delivering economic efficiency 3 times higher than traditional farming. In multi-tiered cage complexes stacked high to the ceiling, the key to this ultra-fast capital turnover lies in the 2+2 model combined with artificial feeding. In nature, parent pigeons must produce crop milk to feed their young, a process that consumes significant energy and prolongs the reproductive cycle. Chinese agricultural engineers have overcome this biological limitation by allowing parents to raise the chicks for the first 7 days, then separating them and transferring them to automated feeding systems. With the support of technology, a nutrient mix that perfectly mimics crop milk is directly injected, allowing young pigeons to increase their body weight 8-fold in just 3 weeks. By removing the burden of parental feeding, adult pigeons can immediately enter a new egg-laying cycle, boosting productivity from around 10 broods to 25 to 30 chicks per year. As a result, meat pigeons reach market standards in less than 1 month. Do you know how thousands of pigeons are transported at once without losing a single one? This is where specialized ventilated trucks come into play, tightly packed with stacked plastic cages, maintaining a massive supply flow from high-rise farms directly to centralized slaughter lines within just a few hours. Beyond providing ultra-fast protein, internal organs such as pigeon liver and heart are often valued up to 5 times higher than regular white meat due to their concentrated iron and micronutrient content, especially the liver, one of the richest natural sources of iron in the food world. In some premium markets, they are even sought after as animal ginseng, although this term is more rooted in folklore than science. Moving into the inland waters of Zhejiang province, you are faced with a massive biological gemstone factory, one that controls up to 95% of the global supply of freshwater pearls. At the core of this system lies a breakthrough technique: multi-point mantle tissue grafting. Unlike saltwater pearls, where each oyster is implanted with a single solid nucleus, technicians here make dozens of ultrafine incisions in the mantle of a living mussel, then insert epithelial tissue taken from another individual without using a hard nucleus. As a result, each mussel no longer produces just one pearl, but becomes a multi-point production system, capable of cultivating 30 to 50 pearls simultaneously in a single cycle, increasing output density dozens of times compared to traditional methods. To ensure consistent quality at an industrial scale, the entire living environment is tightly controlled. Instead of resting in unstable bottom mud, millions of mussels are suspended in mesh bags within oxygen-rich water layers, where growth conditions are continuously optimized. At the same time, biological sensor stations spread across the lake monitor algae density, the primary food source, in real time, maintaining a stable and optimal nacre secretion state, which directly determines the luster and color of the pearls. After 3 to 5 years of nacre accumulation, the mussels are harvested and manually opened with precise incisions to release large quantities of pearls, ranging in color from milky white to pinkish purple. The pearls are then sent through a surface treatment line, where they are cleaned and polished using ultrafine abrasives such as aluminum oxide powder or industrial diamond powder, creating a near mirror-like luster before entering the grading stage. This is the most labor-intensive phase, as thousands of workers must sit for hours to manually sort millions of pearls based on size, shape, roundness, and reflectivity, factors that directly determine their commercial value. With its concentrated calcium and amino acid content, Chinese pearl powder can retail for up to $200 per 100-gram jar when packaged as a premium cosmetic ingredient in the US market. Beyond that, even the shells left after pearl extraction are ground into mineral additives for animal feed, ensuring the entire system operates under a single principle: not a single gram of material goes to waste. On the international market, Chinese pearls have the advantage of low prices thanks to large production volumes and a wide variety of designs, making them highly accessible. However, their quality is often inconsistent, with luster and durability sometimes inferior to pearls from Japan or Australia. In contrast, other countries focus on higher quality, but their products tend to be significantly more expensive. More than 45,000 hectares of specialized farmland are dedicated exclusively to tea cultivation, concentrated mainly in Japan's midland and mountainous regions such as Shizuoka, Uji, Kyoto, Kagoshima, and Aichi. Despite accounting for only a very small share of the country's total agricultural land, the green tea industry generates hundreds of millions of USD annually for Japan. Rather than pursuing mass production, green tea has risen to become one of the 4 high-value pillars of Japanese agriculture, alongside rice, premium vegetables, and specialty fruits. It has helped Japan maintain its #1 position globally in matcha and firmly assert the prestige of Japanese agricultural products on the world market. The secret behind the vibrant jade green color and the irresistible umami sweetness of Japanese matcha lies in its shade-growing technique. About 3 weeks before harvest, artisans cover entire tea fields with layers of black netting or straw, blocking up to 90% of sunlight. In the darkness, the tea plants are pushed into survival mode, forcing them to produce a massive amount of chlorophyll to absorb the scant remaining light. At the same time, this process drives a sharp increase in amino acid levels, creating the matcha's signature calming effect. The result is a tea leaf with highly concentrated nutrients, an almost mesmerizing green hue, and a smooth, gentle sweetness, something no tea grown under direct sunlight can ever replicate. During the harvest season, typically in early May, the intelligence of Japanese agriculture is clearly demonstrated. To meet the global surge in demand, with more than 2,000 tons of tea exported to the United States each year, specialized tea harvesting machines from popular lines such as Valiant and Ochi have become the key for Japan to optimize production. Operating by enveloping entire rows of tea plants, using curved cutting blades to create a uniform dome shape, and simultaneously employing high-pressure air streams to blow freshly picked leaves directly into collection bags in an instant, each machine can process over 1,000 kilograms of green tea per hour, fast, consistent, and efficient, while still maintaining the quality standards required for industrial processing. Once inside the factory, the tea leaves are immediately steamed to lock in their color and halt the oxidation process. After being air-dried to become tencha, the most delicate step begins, removing the leaf veins. All stems and veins are completely discarded, leaving only the purest part of the leaf. This is precisely why Japanese matcha powder is always silky smooth. Finally, the product is finished using massive granite stone mills. To preserve its highly sensitive flavor, the stones must rotate extremely slowly to prevent heat from altering the aroma. It takes a full hour of continuous grinding to produce just 30 grams of powder, so fine that it seems to melt instantly upon touching the tongue. Despite competing with low-priced matcha, Japan maintains its position through extreme meticulousness. This craftsmanship has pushed the price of premium tencha to 56 USD per kilogram, while ceremonial-grade matcha can reach hundreds of dollars for just a few dozen grams. Despite not leading global rice production like Thailand or Vietnam, Japan stands out with premium varieties such as Koshihikari, valued for their exceptional stickiness, subtle aroma, and natural sweetness. The journey of creating glossy rice grains begins with meticulous care right from the sowing stage. Instead of direct seeding into flooded fields, farmers use standardized plastic trays filled with loose, nutrient-rich soil. Once the seeds germinate, Seedlings are evenly distributed at precisely controlled densities to ensure ideal growing space. During their first weeks of life, young rice seedlings are strictly protected like in mini greenhouses by covering the fields with white plastic sheets. This layer stabilizes temperature and humidity, allowing the seedlings to grow healthily despite cold winds. When the time is right, the root systems intertwine tightly to form a solid mat, enabling farmers to lift entire sections of seedlings without damaging a single root. Next, these seedling mats are loaded onto automatic rice transplanters. The machine separates each small clump and inserts it into the mud at a precise spacing of 30 centimeters per row. Straight-line planting helps optimize air circulation, ensure even sunlight exposure, and reduce pests and diseases. Although not a rice superpower when it comes to automatic rice transplanters, Japan is currently one of the world's leaders in technology and mechanization. A Japanese rice transplanter, represented by models such as Yanmar, can handle at least 1 to 1.5 hectares per day, working 10 times faster than manual transplanting, a method still commonly used in countries such as Vietnam and India. After about 150 days, when the fields turn golden, modern combine harvesters move in. Compared to combine harvesters used in the United States, Brazil, or Australia, Japanese machines are much smaller, with a capacity of only about 1/5. Yet this compact size is precisely their advantage, allowing them to operate flexibly on Japan's small, fragmented, and soft field terrain. These machines perform a closed-loop process, cutting the rice, threshing the grains, and bagging them directly in the field, while simultaneously chopping straw and returning nutrients to the soil. As a result, a single machine can harvest and thresh 1 hectare of rice in under 3 hours, replacing the labor of dozens of workers. While Thai jasmine rice, widely regarded as the gold standard of Asian rice, sells for around $2 per kilogram, premium Japanese rice is often priced at over $20 per kilograms, distinguished by its plump, round grains, high stickiness, and the ability to retain a rich natural sweetness even after cooling. Many people think grapes should be soft and juicy, but Shine Muscat, a premium peony grape from Okayama, the sunniest and least rainy region in Japan, features a firm, jelly-like crunch and a sweetness reaching 20 degrees Brix, about 1.5 times higher than ordinary grapes. The secret of Japanese farmers lies in calculated sacrifice. From the moment the vines begin to flower, they prune ruthlessly, allowing each branch to retain only a single best grape cluster, forcing the plant to channel all the nutrients, sugars, and essence, originally meant for dozens of other clusters, into one single entity. Not stopping there, they continue to hand-thin each small grape within the cluster, ensuring enough space for the remaining grapes to grow large without being crowded, while allowing air and sunlight to reach every gap. Not only that, each Shine Muscat grape cluster is wrapped in a special paper bag while still on the vine to block insects, harsh UV rays that can scorch the skin, and even rain droplets that may cause mold. This is precisely why Japanese Shine Muscat grapes have smooth, glossy skins that can be eaten directly, without bitterness or chemical residue. When harvest time arrives, instead of cutting in bulk, farmers measure the sugar content of each individual cluster using handheld meters. Only those that meet the standard are allowed to be picked. Each grape cluster is carefully handled and harvested entirely by hand, like a living piece of jewelry. Farmers use specialized scissors to cut each stem with absolute precision, avoiding any movement that could damage the delicate skin. Once picked, every cluster is immediately placed into a cushioned tray to preserve its perfect shape and natural gloss. There is no mass harvesting, no stacking, only meticulous care at every step. With the enormous labor costs involved in meticulous hand cultivation, each premium Shine Muscat grape cluster can fetch $100 to $200 at auctions or in high-end supermarkets. Leaving the mainland behind, seafood has become the second front through which Japan has built a luxury empire worth around 2.5 billion USD annually, turning the country into one of Asia's leading sanctuaries for high-end seafood. Among more than 400 commercial seafood species, bluefin tuna dominates the premium segment, making it the most sought-after ingredient in the world of sushi and sashimi. The otoro, the fattiest cut from the belly of a top-grade bluefin tuna, can be priced at 30,000 to 50,000 USD, comparable to a luxury sedan such as a Mercedes-Benz E-Class, and sometimes even higher at early-year auctions. Traditionally, bluefin tuna are caught during the winter season, concentrated in the northern Pacific Ocean, using methods such as hand-line fishing or long-line fishing to preserve meat quality. However, in response to rising global demand and the growing risk of depleting natural stocks, offshore bluefin tuna farms have emerged, with Japan being one of the pioneering countries. These kings of the ocean are raised in massive circular cages in deep waters, where currents, oxygen levels, temperature, and feeding regimes are strictly controlled. Automated feeding systems precisely distribute feed, allowing the fish to grow evenly and achieve an ideal fat ratio. Thanks to advanced offshore aquaculture technology, Japan produces more than 10,000 tons of farmed bluefin tuna each year, with an estimated value of at least 700 million USDs, securing the country's position as the world's #1 producer of farmed bluefin tuna in the global luxury seafood segment. At the auction floor, each bluefin tuna is assigned an identification number to precisely trace its origin, weight, and fishing vessel. The fish are then moved into a deep-chilled auction hall, where seasoned traders assess quality solely by meat color, fat marbling, and firmness before placing bids through subtle hand signals. The highest record ever set was a bluefin tuna sold for 333.6 million yen, approximately 3.1 million USD in Tokyo. Once the auction concludes and the fish belongs to the winning buyer, master tuna cutters immediately begin breaking down the fish the same night, separating each cut with absolute precision to preserve freshness, texture, and maximum value. Leaving behind the heart-pounding auctions at the harbor, we return to land to encounter Japan's culinary national treasure, Wagyu beef, a type of meat known for its painting-like marbling and aristocratic care process. The high price of this beef, especially the top-grade A5, stems from a feeding cycle that lasts twice as long as industrial cattle. It takes at least 30 months to reach full maturity in marbling structure. Throughout this period, the cattle's diet is fully personalized, consisting of a nutrient-rich blend of grains, rice straw, and soybean pulp. Notably, to prevent stress, an element that can toughen meat and reduce fat quality, farmers raise the cattle in an environment of absolute calm. At some traditional Wagyu farms, particularly during summer, farmers give cattle small amounts of beer to stimulate appetite. Alongside this, manual massage is used as a stress reduction method, helping fat distribute more evenly within the muscle fibers. A cow is allowed to leave the farm only when it reaches 700 to 800 kilograms and passes one of the strictest grading systems in the world. Only meat with a perfect fat-to-lean ratio, vivid red color, and glossy texture earns the A5 stamp. Wagyu fat melts at around 25 degrees Celsius, lower than human body temperature, creating the sensation of meat melting on the tongue with a delicate aroma. Each cow has its own birth certificate, with a unique nose print to trace its lineage, and the most expensive cuts, such as ribeye and tenderloin, are served at luxury teppanyaki restaurants or exported to the United States and Europe at prices of 500 to 1,000 USD per kilogram, making Wagyu a true symbol of Japanese luxury. You might not know this, but right in the heart of land, once seething with lava and ash, now lie hills blanketed with hundreds of hectares of lush green vineyards. On Mount Etna in Italy, where volcanic eruptions once swallowed entire valleys, people still resiliently cultivate grapes, producing over 15,000 tons each year, with an estimated value exceeding 120 million USD. Without the need for modern machinery, they rely on stones, ash, and skilled hands to build dry stone walls to hold the soil, dig deep holes, mix organic fertilizer with volcanic ash, and carefully plant each vine. At altitudes of 400 to 800 meters above sea level, the grapevines cling tightly to the basalt ash soil, a natural black gold that retains moisture, drains well, and nourishes deep roots. Thanks to the brilliant southwestern sunlight during the day and the temperature differences at night, each grape cluster ripens slowly, developing a rich flavor with a perfect balance of sweetness and acidity. After 3 years of nurturing, when the first clusters swell with early morning dew, the harvest begins. Grapes are picked at dawn, while dew still clings to each bunch, preserving freshness and natural aroma. Harvesters use specialized scissors to gently cut each cluster at the stem, ensuring the skins remain unblemished. Once baskets are full, they are loaded onto the backs of horses or donkeys to be carried to the edge of the fields, because on these steep slopes, trucks cannot reach. The freshly picked grapes are then transported to the winery. Here, the grapes are washed in cold water, pressed hydraulically, naturally fermented, and aged in oak barrels, transforming into Etna Dock wine, priced up to 20 times higher than ordinary wines. From volcanic ash, the people of Etna have created a nectar that the world raises a glass to, a testament that even in places once ravaged by destruction, life and enduring beauty can emerge. Farewell to Etna and its vineyards grown on volcanic soil. Let's explore one of the cold region's most extraordinary delicacies, frozen apples, which are 3 times sweeter and 10 times more expensive than regular ones. Instead of harvesting on schedule, farmers in Aomori, Japan, leave the apples hanging on the trees until December. There, the natural snow blanket acts as a cold coat, causing the water inside the fruit to crystallize while concentrating its sugars and aroma. After enduring several weeks of sub-zero temperatures, the apples turn a deep crimson, becoming intensely sweet and fragrant, a flavor only the harshness of winter can create. Meanwhile, in South Korea and Canada, frozen apples are produced using an artificial snow aging method. Apples are harvested at the proper time, then buried under a half-meter layer of snow for nearly 2 months. Before being covered, hundreds of crates of apples are wrapped in plastic sheets, neatly stacked in rows, and topped with a layer of dry leaves to retain moisture and insulate them. A key step that keeps the fruit from freezing solid, allowing it to soft freeze naturally. Finally, the apples are completely covered with snow, and by February, when temperatures stabilize, the crates are opened to reveal apples at the peak of sweetness and aroma. Though the annual yield is only a few thousand tons, these snow-aged apples have become a high-value agricultural product, a testament to how humans can turn nature's harshness into something uniquely rewarding. About 90% of the world's dates come from the scorching dry belt stretching from North Africa to South Asia, where the desert sun burns so fiercely that the sand itself seems to catch fire. Yet thousands of farmers still climb palm trees towering over 10 meters high to harvest the region's most vital crop, dates. In Egypt, date harvesting is considered one of the most dangerous jobs. Workers rely only on a few ropes, their bare feet, and a simple knife. Under the blazing desert heat and at dizzying heights, they wrap ropes around the tree trunk, climbing meter by meter to reach the ripe clusters near the top, cutting while struggling to keep their balance on the slippery bark. Though safety belts, helmets, and non-slip shoes are recommended, most still work under harsh conditions with meager pay, a stark contrast to the millions of dollars the date industry generates. Today, on large-scale farms, automated lifting machines have become the helping hands that ease labor burdens and boost harvest efficiency. The lifts can extend up to 20 meters, allowing workers to access date clusters more quickly, safely, and precisely, increasing productivity by up to 10 times compared to manual methods. Despite the high investment cost, the improved safety and efficiency make this an inevitable step forward in the modernization of desert agriculture.